I know what you can say. This is just the most beautiful math that has ever been created in the world. I know, and we're getting to study it for multiple hours a day. Okay, I get it. Should stay calm though. Cool, real cool. All right, let's call this the triangle inequality. What did the triangle inequality say? The triangle inequality is a property of vector two norms. In other words, I'm going to probably need what? Let's do, where did he come from? Where did you go? Vector 2 norm, what does it take in? How many? One. We call that a unary function because it only requires one input. Well, really it requires n inputs. But we're thinking about all those inputs as grouped together in a vector, so it's a unary function, a unary argument. What does it produce out? Scalar. The range, of course, is not equal to the codomain. The range is 0 included all the way to infinity, but the codomain tells us the type of output that we expect from that operation. In order to talk about a triangle inequality, which is an algebraic property of two norms, could you guess what I'm going to start with? Two vectors, because that's what I have to put in, right? And then we're going to look at what happens if I compare the two norm of the sum to the sum of the two norms of those vectors. And once again, I should actually leave the punchline to your imagination. Let's go ahead and do this. Let's look at x, and then we'll look at a vector y. What happens if I were to look at x plus y? First I start at the tail, I go all the way to x, then what do? Then I climb along y, and then the diagonal from this to the associated head there would be what? This diagonal from this right there to that, what's that diagonal? X plus y. What about this one? What if I went along y, then I went along x? What would the diagonal be in that case? Well, actually, we started with y, then we went to x, so we might call that y plus x. Does the geometric interpretation correlate with our algebraic interpretation? Am I allowed to first do y, then x? And should I get to the same place as I do x, then y? Why? Excuse me, can you describe that in more detail? Let's not confuse a question for a vector, right? What's the whole idea algebraically of vector addition? Commutative. You're allowed to turn that thing around, right? Now here's a question that I have for you. If we think about this thing as triangles or a parallelogram in R2, or in other words, a parallelogram in the n-dimensional version of a plane, could you guess the relationship between this hypotenuse and these lengths? What should be more, which should be less? The diagonal should be, yeah, my son knows this. Actually, my 1-year-old, my 8-month-old son knows this. When my 2.5-year-old is playing with a toy, so the toy's over here, I'm over here, and my 1-year-old's over here. Do you think my 1-year-old first travels to me, then travels to the toy to grab it away from him? What does my 1-year-old do? He literally knows this in his bones when he's trying to steal his brother's toys. Right? He just literally goes, boom. And I go, oh, triangle inequality, brother. Right? All right. So this is the thing that we're going to do, and I would encourage you to have this picture in mind because then you'll never forget which direction this goes, right? Remember, it's easier to walk around a diagonal than it is to walk along the edges of a triangle. All right, could you imagine what we're going to do when we're thinking about proving that thing? First of all, what do we say about two norms without the square? Two norms without the square, what would you say? Beautiful or hideous? You don't know me. Two norm without a square? Square root. Square roots are very poorly behaved. They do. but so do squares of square roots, right? So let's consider, what did we say about the 2 norm of x plus y squared? What's that equal to? X plus y, inner product, x plus y. What do you know about that thing and sum on either side? This thing is what we call bilinear, which means what? That means I can go x inner product, x plus y, outside of y inner product, x plus y. What do you know about each of those? X inner product x plus x inner product y plus y inner product x plus y inner product y. Now what? 2 norm of x. What do you know about those? Symmetric. What do you know about y inner product y? Okay, and what does that mean? This means immediately that this is x 2 x inner product y plus 2 norm of y squared. But if I take the inner product of x and y, what's the smallest? Well, let's do this for a second. What do I know about x inner product y? What's that equal to? 2 norm of x times the 2 norm of y times the cosine of theta, which says what about the absolute value of this scalar? So I'm using absolute value here because what type of object is this? What does the 2 norm produce outside? Produces a scalar. So I take the absolute value of a scalar. What's the largest that absolute value will ever be? What's it bounded above by? 2 norm of x, 2 norm of y. And what do you know about the relationship between x dot y and the absolute value of x? Ah, sugar. I just gave that punchline away. Which one's larger?
One on the right.
If they're both positive, then they're equal, right? But if this one's negative, this one's positive. So now you know that this is 2 norm of x, 2 norm of y, which means, what do you know about this? What can I bound this above by? We knew that the 2 norm of x plus y squared, well, we just said that that was going to be the 2 norm of x squared plus 2x dot y plus the 2 norm of y squared. But is there any way that you can bound this above by something? Well, what do you know about x dot y? X inner product y, what's it bounded above by? Absolute value. So this is now the, so now this is absolute value of x inner product y. And what do you know about the absolute value of x inner product y? Yeah, so now this is the 2 norm of x squared plus 2 norm of x squared, 2 norm of y squared, plus, 2 times the 2 norm of x times the 2 norm of y, but what's that? How many do you have? Okay, so let me write it in a way that you're more used to seeing it. What's that? A plus b squared. So this must be 2 norm of x plus the 2 norm of y squared. What did we just show? From all this work, we just showed that the 2 norm of x plus y squared is less than or equal to the 2 norm of x plus the 2 norm of y squared, which means what? Traveling along the diagonal is shorter than traveling along the edges of a parallelogram. There's the triangle inequality. Brought to you by the inner product formula for the law of cosines.
The only time in which everything is same is the triangle.
Oh, my friend.
So wouldn't it always be less x or always be a triangle?
Yeah, you know what you just did? Theorem. It should be called the Joe theorem, but it's called the Cauchy-Schwarz inequality because they got the inside track because they're older than us. And now the real thing is, how could you discover that without anybody ever showing you this math, right? But we've set it up in such a way that we almost have no choice. What do you think the relationship is between the magnitude of the inner product and the product of the two norms? Well, what is the inner product? X inner product y was equal to the 2 norm of x times the 2 norm of y times the cosine of theta. What's the largest the cosine of theta will ever be? 1. This implies negative 2 norm of x times 2 norm of y bounds below x dot y. What's x inner product y bounded above by? The positive value. Have you seen this relation? Have you seen that if negative a less than x, less than or equal to x, less than or equal to a, then absolute value of x is less than a, assuming that a is positive? Have you seen that? Negative inside positive. What must be true immediately? Absolute value of the inner product is less than or equal to the product of the two norms. When is it exactly equal? And that was your statement.
When they have a cosine theta equals 1.
When cosine theta equals 1, which means
That they're going the same direction.
theta is equal to either 0 or 180. Which makes sense, doesn't it? Doesn't it make sense that if I brought the 2 norm over here and this 2 norm over there, the largest this is literally asking, if I have 2 unit vectors, what is the absolute largest that length will be? 1. Because if you divided by this over here and you divided by that over there, you'd get that this is bounded above by 1. If you were only like 300 years older, you'd be famous forever. Right? That's where the intuitive grasp comes in of this material.